Hello once again. So, after rage quitting yesterday because I couldn't figure out why GoPG was being just really stupid around querying and executing custom queries, I did some work or research, I guess, after the stream, and I found out the reason why. So I'll be going over the reason why it was broken and kind of more generally just cleaning up the project to get it ready for the next step, which would be hooking up the front end to the API server that I'll run on my server, my personal server. So short stream today because I did 3 hours yesterday, so I'm gonna try to make this sweet and to the point. No gaming, just strictly programming, and yeah. Let's go ahead and switch over the screen. So for anybody who doesn't know, I'm working on what I'm calling the Streamerverse project. And what Streamerverse is basically, let me pull it up, this graph right here. So this graph is called the Twitch Atlas, made by Kieran, I believe that's his name. And what he did was he tracked the viewership for the top 100 streamers during certain sections of the year. And then he displayed it on this graph format you see here and compared all the communities to kind of get this clustering group to show where everybody in the Twitch kind of universe lied. And I thought this was really cool, but I didn't like how it was an image. I thought it could do so much better in a live format, so in a website format, and that's what I'm doing. I'm working to make this image essentially into a live website version with ability to search, filter, click, all that fun stuff. And as of right now, I've got the data collection going, so it's already been running, and I have set up a bit of a front end, and I will be using, I have it right here, the WebStorm project. And I'll be using this API server that I'm writing right now to basically fetch the data from the Postgres server, and so it'll be displayed through the Angular app. But today is mainly focused on just cleaning up the backend project, or the API server. Nothing to do with Angular or any of that fun stuff. That'll be probably tomorrow, because I got to set up a Angular service to fetch the data from this API server. So to start off with, what has changed from yesterday? So big thing is it works now. I can actually query the data, and you can see here, let me limit this because this actually takes a fair bit of time if I'm not running this on my personal server, and that's due to the fact that there's just a lot of data. So if I go ahead and use this is called Postman. It's what I use to do my API calls and stuff like that when I'm testing. And as you can see here, it's running, it's waiting, and it should in short time produce, as long as I'm not mistaken and I just break this yesterday. Oh, whoops, I forgot I had to restart it. Right, I added the limit before I started it. And it was trying to do the entire data stream. And I'll show you what it's doing and why it's so slow when there isn't this limit here. But there you go. See, quickly, here's the just 10 random streamers it picked from the database, and there's no similarities between any of them. But I'll show you why, without this limit now, it takes so long. So if I go here and then I run, actually restart this, and then I run this, watch my network, 24, 55, 86, 96, 98, 99, basically 100% saturation on the line. There is so much data. I have a gigabit line basically between my server and my personal computer, and there is so much data being sent from my server over to my personal computer that it's just being bottlenecked by literally the Ethernet cable, which is insane to think that there's that much data being passed through it. And then after a while, it actually will start going down. The reason for that is there's some caching that's done locally here you can see I've added caching in the form of a sync map. So if I've already fetched the group of viewers from the backend, it will no longer fetch it twice. And you can see here, the CPUs are starting to go up. Network's still high, but eventually what you'll see is that the network will start going down, and then the CPU will just shoot through the roof. Oh, here we go. It's going down, 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 0. That's the point, and 100% CPU usage. This is the point where everything to do with fetching the data from the server has been complete, and it's just 100% load doing comparisons. Lots and lots of comparisons. And if I were to leave this running, it'd take about 3 minutes, 3 minutes 30. So I'm not going to do that, though, because it's going to take too long. But you get the idea. Like, if I don't have this limit in place, where is it? If I don't have this limit in place here, it'll take way too long to actually fetch all the users. So I'm going to limit to 100 just for testing purposes. And in the live server, this limit won't be here. And in the live server, if you want to know for reference, it takes 1:30 to do all the comparisons, because A, it doesn't have to send it through a network cable, it's internal. B, the CPUs running on my server are really powerful. I have two 8-core CPUs running, so 32 threads in total. It's a lot. It's a beefy server, so it can handle this kind of load easily. But my personal computer can't. It's only like an 8-core server, and so I don't want to overload my computer with unnecessary work right now. So the big thing though today is, as I said, cleanup, because as you can see right here, this is what's actually doing all these comparisons and fetching. It's kind of messy. Like, I've got global variables that kind of stick around. I've got a really long function, worker function, that kind of does the same work. As you can see here, this is the same as this. And then I've got some conversions going on for a depend and a log statement that I commented out. But it's really ugly, and I don't like it. And the fact that I have to pass in streamers, but not only that, I also have to use a global variable called links up here to store all the links is not, in my mind, that's not good code. What you don't want to, like, as much as possible, never use global variables. Like, if you can limit your usage on global variables, that is perfect. You don't want to use them when you don't have to. So what I'm going to do is set up a struct. Basically, I'm going to probably move this whole fetching side, this worker basically, and the append, into its own package that'll be more generic, so that I can use it for not only Twitch, but I can also use it for YouTube, which I plan to add later to this Streamerverse graph. For now, I'm just focusing on Twitch because it's a bit easier to do than YouTube is, because YouTube's got some weird finicky bullshit going on with their participation, as they call it, versus the chat room that Twitch has. So I'm not focusing too much on it. Alright, but for now, oh, I guess another thing is I added this renderer. So instead of just writing directly to the header, the response writer here, I use a renderer which will automatically set the content type and render any sort of struct, as you can see here, any sort of object to the response writer to be sent over to whoever's calling it. So that's another thing that's different, but it's not that important. Alright, so how do I want to go about cleaning this up? So I think first off, I need to make a new package, as I said. What do I want to call the package though? Compare? I could call it compare. I guess that would work. Yeah, I think compare is good. Let's call it compare. So new package compare. And let's go ahead and do go file. What do I want to call it? Service? No. Yeah, service, actually. Service sounds good. It's called service.go. And let's see, function compare. Let's call this setup. I don't want to panic. Let's add a struct. This will be our compare service. or compare model, which will have basically just these three things. It'll have the links, which is an array of link, database node. Oh, did I define link custom? Where's link define? Link define's in main. Or no, the link define is here in I'll move this into database. There we go. And then let's export it. Array of links. Mutex is to basically lock the array when we append so we don't get things overwriting. And the viewers cache, which, as I mentioned before, is just caching the viewers that we already fetched from the database so we don't have to fetch them again. So what this will do is it will return a compare. So return compare links, just a map array of link. Mutex, simply enough, is just sync mutex. And viewers cache is simply sync map. Map. There we go. Easy. Alright, now everything's set up. Now, what I want to do is go over to Twitch. Let's cut the worker and append out. Come over to service. Here we go. And see compare worker. That's a good point. Maybe I could include streamers in compare, so I don't actually have to like pass it down every time. It just exists. Where does it fetch streamers? It fetches it here. Yeah, I think I'll do that. I'll include it. Array of database. It's node? Yeah, it's an array of nodes. Okay. And then streamers. Oh, I guess in that case, yeah, I can do this. Streamers. Array of node. Database nodes. Streamers. Ta-da. And then what I want to do is compare dot setup streamers CPR. No, I'll call this comp. And then we'll go comp dot I didn't make this exported. Comp dot worker. Don't need to do that. C dot streamers. None of this stuff needs to be exported, I just realized, because nothing outside of this will actually interact with this. Another thing is I don't like how the viewers is just an array like this, and it kind of has to, like, each worker has to wait on the other workers to append to the array, which kind of slows things down even more. So I'm thinking of making this like a channel, a Golang channel, where it just pushes it into the channel, and then some other, like maybe even the manager itself will write it into, well, I don't know. Something will write it into into the output links. So, okay, so this is s.streamers index ID c.viewer cache ISO week. Right, I was using a constant like this. I guess I'll have to pass that down into the setup. String? Yeah, it's a string. And then it's technically an array of strings. There we go. Viewer cache, streams, view cache, ISO weeks, viewer cache, and there. And then let's go C, compare. c.mutex, c.mutex, c.links, c.links, and then database.link. There we go. c.pendlink. And that should just about do it. Now there's some problems over here. Get rid of this. Database, nope, blank. I guess links is the only thing that needs to be exported, or I can make a function to fetch the exported links at the end, but for now I'll just export it like that. Vector name, there we go. Now it has access to it, and so this will start up the workers, and it'll start up the workers in any kind of fashion it deems appropriate. So I still have the problem of repeating kind of some of the code here, like with fetching the streamer and fetching the two different streamers, viewers. As you can see here, I have something called target streamer and something called source streamer. And then it does something similar where it gets the target map versus the source map, which very similar code paths. So I'll probably pull that out, but for now, let me run this just to make sure I didn't break anything yet. Okay, so it still works. Then let's make sure that I can fetch the streamers still, and there's a limit of 100. Okay. See how long this takes. Not bad, 11 seconds. But yeah, okay. So got the 100, and there's a couple of similarities, as you can see here. Some links with their appropriate weights. All right, cool. All right, so it still works. That's good. It's always great to see. Now let's go back over to the service. All right, now I gotta clean this up a bit more because, as I said, it's kind of dumb that, like, let's see. It's kind of dumb that I have this similar code path here for fetching source streamer versus target map and yada yada, as I just explained previously. Okay, what do I want to do? What do I want to call this? So this is getting. Let's call. What do I want to call this? It's getting from the cache, so I can call it init, initialize, or get. No. Compare. So it's either getting it from the cache, or it's going to go to or it's going to get it from the from the database. So I don't want to call this. Let's call this get viewers. See compare. So this will return a map of int 64 booleans or error. And this takes in a streamer string. Streamer. And it returns the source map. It returns the viewers. Let's call this vector name the viewers. This should be an error, so return format error f nil. Now let's change this around. Let's go this out here, move this down here, let's move this here, and let's go if okay. Actually, I don't even need to, yeah, I can just keep it like this. And then just return. There. Now it'll return early, and I don't have to have excess of indentation. That's another thing. If you're programming, try to reduce your indentation. Indentation always makes things more complicated and annoying. Whereas if you can just keep it simple and to the point, like almost everything on a flat one line, it's a lot easier to read. Like it just makes things easy. Otherwise, you have to kind of think of the code paths and kind of like the iterations and stuff like that. Obviously, it does. If you have to, do it. Don't try to over-optimize that. But if you can reduce the indentation, like I did there, where I had that if-else, and now it's just down to this one if statement that returns, and everything else is kind of just like on this flat line here, then it's good. It's Bucci, basically. So now we want to come up here. Source map error c dot get viewers source streamer. If error not equal to nil, then format a print line error. Continue. Otherwise, that. And then similarly here, we want to go this, and then go error c dot get viewers target streamer error is not equal to nil, format print line error, and then continue. Cool, and there we go. We've simplified the code path. Now we don't have the repeats because it's all down here. And is there anything else I can do? Okay, so this is the other thing I wanted to reduce or simplify. Notice how I'm taking this source map, target map, then I'm comparing the lengths and then reassigning the names as smaller and bigger based on obviously the size. Which one's the bigger one, which one's the smaller one. Well, I feel like I can do this smaller, bigger comparison without having to use these in-betweens. I could figure out early, like right here, or I can figure out here. Source map, I know how big it is. Target map, I know how big it is. And then I'm trying to think. No, I don't think I could. That's annoying. Actually, I got a better idea. Let's once again simplify the code path by moving the function, or moving the code into its own function. Simple. Compare. So source or source and target. These are map int 64 bools, and then it'll return a uint for the comparison. Then we take this out, put it in here, target, source, get that, and then return count. Count. There we go. Doesn't really need to be part of C, considering that it doesn't call C at all. But I felt like it was float 32. I'll just return an integer, and then if it wants to convert it, it can. I'll just make this a helper function. Oh no, I can't, because it overloads the struct name, unless I named it like compare maps. Actually, I can name it like, take this out and then go compare viewers, and then I can go like this, count, compare viewers, source map, target map. Float 32, float 32, and there we go. Like, look how simple this is now compared to what it was before, where it was just this large function that had almost like 4 different things pushed into it. Fetching the viewers is now simplified. Comparing it's now moved out. I could keep it here, like it's not that big of a deal, but I just wanted to make it a little bit cleaner. Now the only thing left is, as I said, doing this appending. I don't really like this because it locks every single worker, obviously with the lock here, until another worker is finished writing so that they can continue. So it kind of puts more delay on the system. And I want to alleviate this by using what's called a Go channel, which is thread safe, so you can write to it all at once. Any worker can write to it, and it will be able to handle it without any locks or anything like that. So it's really nice to have. So, but for now, let me just refresh this, make sure it's still running properly. Send it. $10 that time, so it was a bit faster. And yeah, it looks about the same. Don't actually remember if it's the same, but it looks good. Seems like it's working as intended still. That's always nice to see. Alright, so next step. I want to get rid of this links and mutex. So let's remove this. And let's remove that. Let's remove this append. And then let's add in I can make it so that either it does it or yeah, let's do it like this. Let's make it so that the caller has to pull out everything, pull out all the data. So it's a channel of database links. Okay, and then what we do is we go c.links, write that into database link, source streamer, target streamer, and weight count. There we go. Now that should be good. And we go over here. Now once this is finished, what we want to do is we want to read everything from the Go channel. Comp.links. Did I make that a capital? I did. I don't need to make that a capital. Now let's read it. I believe. How do I do it again? Let's look this up. Golang range over channel. Oh, simple enough. I don't even have to do this. I just do that. And then do that. Okay, and then link. Links.append assign link, and there we go. I've got myself all the output with none of the delay that comes with appending to a what's it called? With appending to an array with a mutex lock. The problem with this though is it doesn't close the channel. As you can see here, you should probably you really should close the channel. It would garbage collect it technically, but it's better practice to garbage collect. Let's func see compare get links I'll add it here. I'll do it for the caller. One, because I want to close it properly. Two, because why not? It's not like it'll hurt me to do this. And oh, get links. There we go. And let's add this here. Okay, that looks to be good. And then let's close the channel so that we don't have any leaking memory. C.links. There we go. Cool. And then return links. Actually, I'll do a defer statement because that's good. Defer. I like using defers. They're fun. So that way, whenever this returns, it'll automatically call this code up here without having to call it explicitly down here. It's kind of unnecessary, but I like defer statements. They look cool, and they're kind of a unique property of Go. Okay. Back to Twitch. Get links. This should be good. All right, let's refresh it. Make sure it still runs, still compiles. Yep. Now let's run it. Did I break something? I think I might have broken something. That's not good. Alright, looks like something might have tripped up along the way. What could it have been, though? Oh, I think I know. I think I know. it probably doesn't like writing to this channel because it's probably a buff. So in Golang, there's things called buffered and unbuffered channels. And I think this is a buffered channel here when it has the parameter set for 2. And what I'm doing is what's an unbuffered channel. And I think writing to an unbuffered channel, it locks it because it doesn't expect the extra data. That might be it. Damn. Golang unbuffered channel. Let me see. I think I might be right. An unbuffered channel is a channel that needs a receiver as soon as message is emitted to the channel. To declare an unbuffered channel, you must declare. Okay. Channel defer write foo. The first go routine is blocked, sending the message foo since no receivers are ready yet. Its behavior is well explained. Okay. Oh, that's yucky. So basically, what's happening is when I'm writing into this channel, it expects somebody to read it immediately. If there's nothing reading it immediately, it'll block the go routine. So it'll block the rest of the call of the function. So it'll just sit here indefinitely until something starts reading from this channel, the links channel. What I could do is make this a separate go routine where it automatically pulls the data down from the go channel, or I could make it a buffered channel and specify how much data is being put into how much data is going to be put into the links. But I don't know that. I don't know ahead of time how many links are going to be put in. I know a maximum how many links are going to be put in because I could do like a combinatorial, like, oh, how many source streamers there are versus how many target streamers there are, and then I could figure out, oh, okay, that means there has to be 4,950 or whatever number links at maximum. But I don't think I really want to do that. I think it's better if I just make this a go function, a separate running go function that just pulls the data down continuously. But how would I guess I could I would know when it's done because the channel would close. And here's the unbuffered version where you can write in anything you want and then read it out at any time you want. This is just benchmarking. I don't really need to know about benchmarking performance. How do I want to do this? I think the best way to simplify this problem would be to call the function here like this, go dot. Oh, I'll need to declare the struct, the object first, and then go dot c dot. What do I want to call this? Right now it's called get links, but I don't want to keep it as get links. I want to rename this to, and I also don't want to export this anymore since it's going to be internal. What do I want to call it? Read results. I guess I'll call it read results for now. That sounds good. And then what I want to do is an infinite for loop. Which, let's say, results. Now let's go link range of c dot links. So this will keep going so long as links is open, I imagine. I don't know for certain. I'll have to test that. Results, read results, and then return C. There we go. let's change this into results to match the function name. Keep it unbuffered. Results link, and then link c dot. This doesn't return anything anymore now. Now I have to add back in the output. Let's remove this. I don't want this to be called results anymore. I don't want this to be exported, sorry. Links, and this is what the caller will read. Node? Node. Or not node, link. There we go. And c dot links dot append assign link. Defer come on. Close c dot results. And now I think this will continuously read so long as results are being put in. Or I guess no, this won't close it. This will close it. So when this is done, we'll go c dot. Oh, that's a good idea. Actually, I just thought where is it? Service, here it is. I'll just add a function right underneath it called c compare get links. So as soon as links, turn c dot links. As soon as somebody or the caller asks for all the links, it'll just close the results channel, which will stop this function from iterating, and it'll cancel out this go routine. Database link. There we go. That should do it. Let me just read through this first before I run it, just so I'm not forgetting something. Alright, so start off with, we create the object that will return up. We start up the read results go routine that actually takes all that data that's being churned by the worker and adds it to our output of links. Output. I'll just call this output array. The worker fetches all the data, compares the viewerships between the two streamers. We check to make sure that each streamer, the amount of viewers between the two streamers is greater than 30% of their viewership. If it's greater than 30%, then we say that's significant enough to say that they are linked in a graph. Up 10 because there's 10 workers. That probably should be decided up here in the setup, but I'll keep that here as hard-coded for now. Best practice would be to set that here. You'd pass in like how many workers you're running, and then it'd be stored within the object, so it's dynamic. Read the results, and then when we call get links right here, it'll cancel out the go routine, or the go routine reading the channel, because it'll close the channel. This will return, and then it'll return the links, and then that should be good. Okay, yeah, I think that should work. Let's try it. Should compile, yeah, nothing wrong there. Now let's try running it. Hey, look at that. It worked. Beautiful. Beautiful. And that means that this was called, so it closed the results channel, so this would have closed, which means this would have been, yep, okay, cool. Everything works as I thought it does. Beautiful. And it even went down a bit in time. I don't know if that actually is significant in the way I've set it up, but the first time I ran this today, it was at 11 seconds. Then after a couple of improvements to the code path around duplication, code duplication, I should say, it went down to 10 seconds 30, and now we're down to 9 seconds 89. So it's slowly lowering the runtime. So that's good. That's always nice to see. But again, I'm already limiting it by 100. If I were to run this on my server without this limit here, it would take 1:30 because there's a lot of data being pushed over this line. Like more than a gigabit per second of data is being transferred, and that's way too much for my computer to handle. So I'm just limiting it now so I can actually run this code and test it properly. So that looks good. Is there anything else I want to change up and optimize before I move on? No, I think that's good. So I've got my endpoint set up. Oh, I guess that's fine for now. That's hard coded here, but I probably should make it so that when you query the endpoint, you specify something like can't spell ISO. God damn it. ISO weeks equal to blah blah blah, and then it would read it from this query parameter here, and then it would input it here instead of just being a hard code. I think that would be the better way of doing it. Or it should be the way I do it, but for now I'm just going to keep it hard-coded because I'm I'm lazy. Okay, let me go ahead and copy this data over. Actually, let's keep this over on this side. Copy the data. Control-C, Control-V. Open up the display. Assets, data. This is from yesterday. I was testing it. Actually, here I'll run this and show off what the graph looks like. Well, it compiles. I think is this all 100 streamers or 1,000 streamers? No, this is definitely not. Is it? Oh no, it is. This is every single streamer. Yeah, so this you're about to see what happens when you try to graph 1,200 streamers without any proper setup with your forces on this graph, because it gets pretty clustered, and it also shits my frame rate. Oh, this also might be the first time I'm showing off the fact that I was able to get the names to show up in the center of each of the nodes, which took me a bit of finessing. As you can see here, I still have some like sloppy code of calling something thing and referencing viewership in two different places, even though it's kind of not a proper attribute of the model that it's referencing. But I don't care. This will have to be cleaned up at a later date as well. Building the application. I really hope that I can get it to kind of the same layout as this, so that would be great. I looked in some clustering algorithms for Angular. I didn't try them out yet. Oh, it looks like it's done. But I'm hoping that they work as intended and they are fast enough and don't shit on it. So there you go. That's what it looks like trying to display 1,225 nodes. They're all trying to push each other apart. You can see the links underneath the white lines. And it's shitting my frame rate probably right now. But it does display them. And then you got some random people out here who have no connection to anybody. Who's this? I don't know who that is. Who are these two small asses? Don't know who that is. Don't know who that is either. Okay, looks like it finished. Riot, the behemoth, along with XQC, another giant name. So what I'm hoping is that with the clustering algorithm that I'll use, it'll be able to push all these nodes apart and put them more into groups like this, where you see like orange is further over here on the left, you got blue, red. I'm hoping this clustering algorithm will pull all these nodes apart from each other, because right now they're just shitting themselves together in the center. Like if I remove this, the force center, I think that might push it out a bit further. Let's see. Nope. They're still stuck together. Oh, I know what I can do. This will probably force them apart, but it'll look really bad. D3, force, link, distance, and let's push them 1,000 pixels apart from each other. Let's see how they react. Oh, look at them go. Who the fuck is down here? What? There's nothing there. That's what happens when you try to say that you have to have a distance of 1,000 pixels for every single node. They just collapse on top of each other. Who's the center? Who is a world? Okay, you're the center of Twitch now. Computer chess as well, and so is Volcom. But yeah, it's really hard to get them to display properly without a clustering algorithm, because they just basically don't know how to react to each other in a like more stylistic way, I guess. Because like the original author actually hand moved some of these nodes around, which is great because it's an image. But for me, I can't just hand move every single person's cluster or graph. I have to program it so that it is able to render it without shitting itself like this. Alright, so let's see. What can I do? Let's copy the data over, I guess, from the run I just did. It's here. Control C, Control V. This is what it looks like with a small amount of data. See, look at that. Look how cleaner that is. Aiden Ross annoying. That's that's unfortunate. Aaron plays 39 def. Yeah. XQC isn't in this graph because again, this was limited to just 100 random people, and they didn't pick. The database didn't spit out XQC as one of the 100 random streamers. Just kind of looking to see. This is kind of what I'd want. This is kind of the layout that I'd want when it finishes. But there's just so many people and there's so many links that it tries to keep them closer together because of all the links. Because you can see here, like, look, these two people are linked, and then it tries to keep them closer together, versus people who are not linked, and then it just kind of pushes them further apart. So the link is kind of pulling them together a bit, which you want. You want things that are linked to be closer together, but you don't want them to be too close together, is what I'm thinking. I might be able to change the force of the link to actually push them apart, but I'm not sure. I'd have to look more into this, and that'll probably be what I do tomorrow. Actually, I'll probably play around with the rendering now that I've got the API server kind of in a state that's good enough. I'll probably put this up on my production on my server and just kind of run it, and I think that should be good. Is there anything I want to change? Let's see. Maybe I should add logging for the requests. Let's see. Go chi, there it is. What's the middleware? Logger. Let's log the request. Hopefully it doesn't spit out my IP address. That'd be annoying. And then let's run it. Is it not going to log anything? Or does it log it? Oh, there it goes. It logs it when it finishes. Okay. No, I just logged my local IP, so that doesn't matter. That's good. I like that. Oh, right. I still got those debug messages. I should get rid of that. I just realized. Get rid of you. Get rid of you. And hopefully one day I'll have YouTube set up for this as well. But for now, it's just Twitch. All right, cool. That should just about do it. Actually, I think I'm done for the day now. I think this is all that I'll do. Yeah. All right, I think I'll call it quits now. Short stream. I spent 3 hours yesterday banging my head against the wall trying to figure out why the database wasn't working. So I don't want to spend another 3 hours just kind of middling around now that I got everything working. So yeah. Cool. All right. So I guess for tomorrow, what am I gonna do? Let's see. Tomorrow I'll work around on the Angular project, kind of finish up the displaying, and I think it's in the project's in a good state where I'll contact the original author of the Twitch Atlas, so the Kieran, I believe his name is, yeah, Kieran, and see if he wants to help me out further on the project, because there's still a couple things left I could do to like really bring this home, and it'd be really nice to see if, to get some cooperation with him on this, because he's the original author, and I think he's having to pay like $100 a month to run a compute engine server, which kind of sucks, and I can run this for him on my server for free charge. So I think I'll do that maybe tomorrow or after. But yeah, all right, cool. Thanks for checking in. If you have any questions about like Golang or anything kind of related to API servers, maybe not too specific about API servers. I'm not that good with programming. I'm happy to help. Like, if anybody wants to know some things, I can respond if I know, or point you to resources that might be better. But thanks for checking in, and I'll see you guys tomorrow. Bye.